This is level 4, combined sector properties. So our essential question is, in the right program maybe, how do I find area and perimeter of combined figures? So using the same formulas we've been doing, arc length. So S is the angle over 360 times 2 pi times the radius. And the area formula is, again, what part of a circle are we talking about, times pi times the radius squared. So remember, the radius is from the center of a circle to a point on the circle. Arc length is part of the perimeter, the circumference of a circle. And then area would be the filled in section. So when we're doing this, we're just trying to find the area of the pieces that are shaded. So you have to remember a couple of things about circles. You have to remember that any point that goes through the center all the way across to 2 points on the center is called the diameter. That means it cuts a circle in half. Half of a circle is 180, so that's automatically a diameter and 180 degrees. So this theta 1 is 180. And then if that's 180, then this piece is 180. And then if this is equal, then these are equal. So that means this is 73. So this piece is 180 minus 73 minus 73, which is 34 degrees. So that's theta 2. And so when you look at that, I can do this a couple different ways. I can either say that I have a big circle minus 2 pieces, right? Or I have a half circle plus this little wedge. Those are the two ways that I can solve this picture. And so if we do it the first way, then we're looking at the formula for a circle is pi r squared. Remember, we're doing area minus 2 times, and I just want to find the area for this. Well, the area for this, and I didn't write it on this paper, I apologize, SR equals 20. Nope, 10. So this piece, this whole line, is 10. That means that half of it is 5. So that means that that's my R, my radius. So this is theta over 360 times pi r squared. So when we plug in pi 5 squared, that's the whole circle, minus those 2 pieces. Well, that's 73 over 360 times pi 5 squared. So this piece right here is the formula for this area. So I took a whole circle, and I'm just going to subtract out those 2 pieces. So when I do that, I get that my area is 46.7. We're asked to round to the nearest tenth, so that's why we have 1 decimal point. If I do it the other way, then a semicircle area is 180 over 360 times pi r squared plus 34 over 360 pi 5 squared instead of r, because we already know that radius is 5. And I get the same thing, 46.7. So you can do it two different ways. It just depends on which way you see it and how it makes sense. When we look at the second problem, we have a square and we're subtracting out some circles. Because the circles touch on the edge and touch all the way, you are to understand that that makes the diameter of this circle 6, which makes the radius 3. And that's the case all the way across because they appear to be equal circles. So what I have in this diagram is a square minus 4 circles. So if this is a square and this is 12, then this is 12 squared minus 4 times, let me erase that and do the formulas first. This is side squared minus 4 times pi r squared. So this is 12 squared minus 4 times pi 3 squared. You can put that in the calculator all at once, and I get that my area is 30.9 centimeters squared. Don't forget to use units when they're given to you. An area is always squared. All right, this next shape is a trapezoid. It's called a regular trapezoid, and an isosceles trapezoid because these sides are the same. So what you have here is a trapezoid, pretend that I know how to draw, minus a circle. The formula for a trapezoid is half the height times the sum of the bases, so base 1 plus base 2, minus the circle that we have inside, which is pi r squared. So we start labeling some things. My radius is 4. My height is 8. Base 1 and base 2 are the 6 and the 15. The 10 is called a slant height. That's not important for us right now. And so now that I've labeled everything, we just need to plug it in. So this is half of 8 times 15 plus 6 minus pi times 4 squared. And of course, this is still area. So I can put that in the calculator all at once and get, maybe I didn't do that one. Do that one already. Four times 21 minus pi times 16. So that's 33.7 feet squared. So that would just be the area of the shaded part. Now we're going to find area and perimeter. Perimeter is, remember, think of that as fence, so it goes around, and area as carpet. So the perimeter is going around, so I need 2 arcs, and I also need these 2 straight pieces. So we're going to call this S1 and S2. Notice that for S1, my radius is 5, 2 plus 3. But for S2, the radius is only 3. The angle stays the same, but the radius changes. So when we look at this, perimeter is S1 plus 2, so that's going S1 plus 2 plus S2 plus 2. So S1 is theta over 360 times 2 pi r. My angle is 120 times 2 pi, and the radius for S1 is 5. So to get from here to my arc S1, that's 5. That's where that 5 comes from. So S2 is, again, theta over 360 times 2 pi r, which is 120 over 360 times 2 pi. This time my radius is 3. To get from the center of this sector to my arc is only 3 centimeters. That's why the difference between the 3 and the 5. So when I put this in the calculator, I do it all at once. I put this, because that's S1, and then I say plus 2, and then I put this, and then I say plus 2. So I do it all at once so that there are less things that I have to worry about typing in fewer times. And so when I do that, I get that the perimeter, is 20.8 centimeters. Now remember, perimeter is not a squared unit, so that comes from adding those together. So I added this into this, and these are 2's to work. So that's how we find the perimeter. To find the area, it's pretty similar. I'm going to find the area of the big pi piece with a radius of 5, and then I'm going to subtract out the area of the little pi piece with a radius of 3. The angle is still 120 for both pi pieces, but I'm going to find the area like that. So this is 120 over 360 times pi 5 squared minus 120 over 360 times pi 3 squared. Remember, our radius is changed because we're talking about the whole thing versus just a piece. And so when we put that all in the calculator, and again, I do it all at once, that equals 16.8 centimeters squared. When you look at this next shape, what do you see? Here's what I see. I see a semicircle. I see another semicircle. And I see a really big semicircle. So when I'm looking to do the area of this, I think that I have a small semicircle, and then I'm going to add a really big semicircle, and then I'm going to subtract a little bitty semicircle. When I do this, the radius for this semicircle is 6. The radius for the small one is 3, and the radius for the big one is 9. So this is 9, this is 6, and this is 3. Now, to make it easier, they're semicircles. Semicircles are half of a circle. So I know that the thetas are 180. So if I'm doing 180 out of 360, that's actually half. And for the purposes of using a calculator, that's the same thing as 0.5. It just makes it easier when you're entering if you don't have to use the fraction key. So this is 0.5 pi 6 squared plus 0.5 pi 9 squared minus 0.5 pi 3 squared. Now this is for area. So we put all that in the calculator, and that is 169.6 centimeters squared. That's the area. To find the perimeter, we have 3. I have to go this far, so I do that arc. That's S1. And then I have to go this way. That's S2. I'm still going in there. Even though it goes inside, it's still going to be part of the fence. And then the last piece around is S3. So my perimeter is S1 plus S2 plus S3. Remember that S is the arc length. So when I plug that all in, again, these are semicircles. It just makes it easier. Instead of putting in the fraction every time, I'm just going to put a decimal. It's the same thing. 0.5 times 2 pi 6 plus, this time it's adding, not subtracting, 0.5 times 2 pi 3 plus 0.5 times 2 pi 9. I put that in all at once and get that my perimeter is 56.4 centimeters. Not hard. It just takes some understanding of what you're doing, and then you're just adding them all together. Last one. I see a semicircle here and a semicircle here. But this plus this equals a circle. So what I really have is a rectangle plus a circle. I could do it with 2 semicircles. That just seems like more work to me. Now I have to have some understanding about how shapes work. If this is 7, then this piece is 3.5. And if it's 3.5 from the center to the circle here, then this is 3.5. And the same thing goes over here. So this piece is 18 minus 3.5 minus 3.5, which equals 11. That's important because I need to figure out my area and my perimeter. So area is pretty easy. This is base times height plus pi r squared. That's my radius. Base times height of my rectangle, that's 11 times 7 plus pi 3.5 squared. So the area is 115.5 meters squared. Now for perimeter, I still have a circle, but I only have the top and the bottom of the shape. I'm not doing the sides. If I put a fence around this whole shape, it doesn't go here. So I just need to do 11 plus half a circle, 11 plus half a circle. So since it's two half circles, we're just going to do a circle. So this is 2 pi r plus 11 plus 11. So 2 pi 3.5 plus 22. And my perimeter is 44.0. It was actually 43.99, but that goes to 44.0 meters for my perimeter.